Assalamu alaikum. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbi zidni ilma. Children, today we are going to discuss the chapter that is very important. Easy, but you need to know how to remember the basic things. This is chapter number 3, hardware. In this chapter, the most important thing that you need to know is the computer architecture, the von Neumann, the use of ALU, CU, and registers, the buses, the purpose of different buses, and then the terms course, cache, and internal clock. What are they and what is their purpose? And one more important thing is fetch, decode, execute cycle. It's not difficult if you pay attention to the minor things that you need to know. It's not a difficult thing at all. You can manage it very easily. Then embedded system. That is again very simple, not a difficult thing. Just remember something that you keep on observing in your real life. So it's something similar to that one. Input and output devices, again, I'm reiterating, you only need to know the purposes, the applications of different input and output devices, and you don't have to rote learn the working of any of the input and output device at all. Please be clear. If you have a few questions seen in the earlier papers, they were there early, but now this topic is not a part of the syllabus anymore. Then most important thing is your sensors and their applications. Very important thing that you need to know. A very simple way of remembering and answering also, I'll let you know how can you score here also. Then moving on to data storage, very important topic. I'll discuss that also. Then network hardware and cloud storage and virtual memory also. Let's see. If you have a query, then you can raise your concern in the chat. I'll be able to answer your query just then and there, inshallah. Now, moving on to the first thing, architecture CPU. Basically, central processing unit is your, just like the human brain, and it is there to process different instructions which are given to it. And it is basically based on mainly three components. It is ALU, CU, and registers. So what you need to know is the working of the control unit. And before that, von Neumann architecture, why was it needed? What is the advantage? Before the von Neumann architecture, what was happening is everything was on the computer in the hardwired form. So there was no concept of program, there was no concept of data storage, everything was hardwired. And then to solve the problem of the consumers, of the people, then the idea was, can say, propagated by a person, von Neumann. And based on his idea, the whole concept is given the name von Neumann architecture. What you need to know, maybe a question of 2 marks or 3 marks can come in the paper that may ask you that what is von Neumann architecture. So you simply need to know the earlier computer systems and the newer ones that are using the concept of stored programs. The concept of CPU, the concept of CPU able to access the memory, as well as the memories are able to store the data and the programs, and not hardwired the way they were earlier. Now, very simple thing, not difficult. Then what you need to know is the purpose of ALU, arithmetic and logic unit. Very simple. It is there to perform arithmetic, which is plus, minus, multiply, and divide, basically plus, minus. And the use of logic operations means that it can decide that which one is the highest value, which one is the lowest value. Some sort of sorting is done. And that is what the function of ALU is. So, yes, exactly. It is, you are absolutely correct, Yaya, that it's there to solve the problems, arithmetic problems as well as logical problems. Exactly, exactly. You're absolutely correct that this is what the purpose of ALU is. Now, moving on to control unit, as the name implies, it's there to solve the, you can say it's there to help you in everything that is managing, you can say. It is there to manage everything happening in the computer system. So whatever is written here, fine. It is there to the address of the location where the instruction can be found is stored in program counter. We will discuss it right now. But its main purpose is to see that everything is happening properly or not. So you can see it's basically going to help you in fetch, decode, execute cycle processes. So this is what we will definitely be discussing here. Then you need to know one more thing, and that is RAM, which we already know. But another name for RAM is IAS. So if a question comes in the paper that what is IAS, so don't get confused. It's the same as RAM is. So you can see it's another name for RAM. Third thing is the registers, and here you need to know the purpose of the different registers. So for this purpose also, I'm giving you a hint. You need to actually remember the CIR, current instruction register. One more suggestion. If you think that you can't remember the complete full form of the different registers, so no worries, what you can do is you can simply write down the short form also. That's perfectly okay. You can say CIR, which is storing the current instruction to be processed, to be decoded and processed, worked upon, is basically CIR, current instruction register. Then PC is holding the address of the next instruction to be processed. So program counter, the word counter we have been using quite often in programming. So something similar to this concept you can see here is also that it is going to work on the next instruction. Then we have ACC, again, accumulator. This register is used when carrying out ALU operations. So you can see, yes, you are absolutely correct. So when you talk about ACC, this is the register that is there to carry out the ALU calculations. So you can say it stores the data temporarily during the calculations. So whatever data is there during calculations, that is stored in your ACC, accumulator. Then after that, we are left with MER and MBR. MER, as the name implies, is there to store the addresses, and MDR, as the name implies, is there to store the data. So here you can see data is stored in MDR, and which data? The register stores data which has just been read from memory or data which is about to be written to memory. So simple, very simple thing. Just concentrate on the keywords data, and you can see this is actually storing the locations. This is actually storing the data that you are working on. Maybe you are reading the data from the memory, or you are writing the data to the memory. So they all are held in your MDR. Then next one is MER. As the name implies, memory address register, that is storing the address of the memory location currently being read from or written to. So this is what you need to see and remember, and then you are through with the whole process of even fetch, decode, execute cycle. So I think there is no problem in understanding the purpose of the 5 registers. PC, CIR, and then ACC, completely different. And then lastly, we have a set of MER and MDR. This I can remember for a longer time. Any questions before I proceed to the buses? Yes, any questions? Okay, now that's
No,
wonderful.
miss.
That's wonderful. Now let's move on to buses. As the name implies, buses, what are buses basically? They are wires. And these wires are there to transport. And what are they transporting? They're actually transporting either the addresses, or they are transporting the data, or we have the control bus. So there are 3 buses that we need to know. The first one is my address bus, as you can see. Just remember the sequence also. Address bus is unidirectional. And what is it doing? You can see for yourself. It's there to carry out as the name implies, the address bus is carrying out the addresses throughout the computer system. And between the CPU and the memory, the address bus is unidirectional. And unidirectional means it is it is in one direction only. And it is from the memory. If I can, you can see it cannot be between the CPU and the memory. The address bus is unidirectional. That is, bits can travel in one direction only. It prevents the addresses being carried back to the CPU, which would be an undesirable feature. Now, this is a question can come in any form, but what you need to know is address bus is unidirectional, and it will not be carrying the signals back to the CPU. And now, one more thing, width of the bus, the wider the bus is, definitely more data can be accessed, more data can be worked upon, more addresses you can say, addressed. And second one is my data bus. As the name implies, data bus is there to carry the data. And it is bidirectional. As you can see, it's going to allow the data to move between the CPU to the memory, and vice versa. Also, it can take the data from the memory to the CPU as well, and from input to and from the input and output devices. Now, another important thing is the control bus, which you can see is bidirectional. It carries signals from the control unit to all the other computer components. And it is usually 8 bits. Now, very important thing that you need to know is it is okay if we have an 8 bits wide control bus, because there's not any need to have a wider bus. 8 bits are supporting the purpose, so there's no need to go further. So these are certain important things that you need to know if a question comes in the paper. at least you will be able to answer from this topic also. I mean, questions can come in any form, but you need to be well versed with your own learning. So any questions before I proceed to the next topic? Yes, are you clear? Now we have talked about the buses, we have talked about the registers, and now we are moving on to fetch, decode, execute cycle. Now I suggest you what you can do is you can simply move on to this very easily if you pay attention to the minor things that you need to know. From here, I can actually form a complete fetch, decode, execute cycle, can say whole process. You can see for yourself. First stage is program counter contains the address of the memory location of the instruction which is to be fetched next. This is what we have discussed just now. Address is copied from PC to the memory address register. So if you make a shortcut, like if you say memory address register is your target and PC is your source, so you can simply write down that MER equals to PC just for the purpose of remembering so that you're not making a mistake when you are preparing for your papers regarding the execute cycle. You just make a shortcut. You say MER is your target because the data is moving to MER from PC. So if I just make a shortcut MER equals to PC, that's perfectly okay. Then next thing is from the MER, the data is then copied to MDR. So in this case, MDR is my target. So I will say MDR equals to MER. Then so the MDR, you can see this third one, contents of MDR are copied and placed into CIR. So what can I write for this whole thing? What is the best way to do? Yes. How can I write this box? The contents instructions of the MDR are then copied and placed into CIR. I can simply say CIR equals to MDR. So in this manner, and then PC is increased by 1, as we talked about in the beginning. It's counter, that means the value is going to be increased by 1. So that is why PC equals to PC plus 1. And then the final stage is decoding the instruction and executing it as your desire. So in this manner, if you actually, yes, wonderful. Yes, that's what I wanted. So if you pay attention, then you will be able to understand this whole concept very easily, and you will be able to remember this also. So this fetch execute cycle and questions of this form are coming quite regularly. So you will be able to score also if you have understood this whole concept. So the next one is cores, cache, and system clock. But what are cores actually? If you know the term cores, what is a core actually? Yes. Exactly. You're absolutely correct. So actually, what you need to know is the factors on which a system's performance is dependent. By the way, this question is again is coming in the paper. Factors that need to be considered when you are trying to increase the performance of your computer system. Factor number one is the width of the bus. If you definitely can see, if I talk about increasing the width of the bus, so definitely it will improve the performance of my system, isn't it? So width of the bus is one factor on which your system is dependent. Overclocking is factor number two, which you can see this the clock speed can be changed by changing the BIOS settings if you really know. And once you alter the settings, then you can actually make it work a little faster. But remember, clock speed can be increased to a certain extent. For example, if you are trying to overclock, if you're trying to increase the clock speed to a value which it cannot handle, then it becomes a little problem for the computer to handle, and that is called overclocking. So this is what you need to know. And next, it's the cache. By the way, if you just know, cache is basically a form of your SRAM. So if you are if you want to improve the system performance, then you can actually increase the size of your cache also. It means it can store more data. You more frequently store data is stored in cache. So if you have more cache, if you're able to utilize the cache properly, then definitely that results in improving the system performance. Then we have fourth point is the use of more cores, and then it will be dual core or can be quad core. So dual core means two cores, and you can see one core is made up of an ALU, a CU, and the registers. It's just like the complete CPU that we talk about, but the only change is dual core means two cores working together, and quad core means four cores working together. Yes, correct. You are absolutely correct. You know, Yaya, that I like you are able to recall and answer. That's wonderful. Quad core, four cores, and definitely you can see still a question can come in the paper. that even if you have increased the cores, still system is able to perform the things to a certain extent, and you cannot make it work beyond its capacity. And what the problem of you can see, we have talked about this overclocking also. So what are the four factors that you need to know? First one is the width of the bus, which can be address bus and data bus, never control bus. This is what we have talked about. Second is overclocking. Third one is use of cache. And fourth one is increasing the cores, dual core and quad core. So any questions before we proceed to the next topic? Yes. And this is summarized here also. So you can actually talk about the same summarized here, increasing the bus width and increasing the clock speed. Then fourth one, it's your altering the bus width and clock speed and use of multi-cores. And lastly is the use of cache. So these are the four factors on which system performance is dependent. Now, let's talk about instruction set. What you need to know is the instruction set. Basically, the instructions are a set of operations which are decoded in sequence. Now, this is the definition that you need to know. Each operation will insert the ALU and CU to perform some activity, and you need to know the term opcode and operand. Simple. Opcode is telling the CPU what to do, and operand is what the data is worked upon. So simple thing. Operand is the data or the instruction that is the data which needs to be acted on, or it can refer to a register in the memory also. And opcode is actually the command that is given to the CPU to perform any activity. So this is the main thing that you need to know, beta. One thing is, I'm not actually talking about anything in detail. I'm just discussing the things very quickly so that you all can comprehend and remember for a longer time. Any questions till now? Instruction set we have talked about. Yes, if you have a question, then you can raise your concern here. Like definitely, I'll be answering your query. Yes, exactly. If you are adding 2 and 3, then 2 and 3 will be your data, and plus if you say 2 plus 3, so plus is the opcode that, or the instruction that you are telling the CPU to perform. And for example, the instruction that you are giving is opcode, and on what you are working is going to be operand. Now, moving on to a very important thing is embedded system. By the way, what kind of questions can come regarding embedded system? Firstly, what is an embedded system? Do you know what is an embedded system? Something that is a combination of hardware and software which is there to carry out a specific set of functions. And what you need to know is maybe embedded system is present in your household appliances, like your microwave oven, your refrigerator, iron. All these things have embedded systems. This is the simple thing that you need to know. For example, this is the can be based on microcontrollers or microprocessor or system on chips. So if this is what you need, just try to understand and remember these three basic principles, and then you will be through with questions of any form that come in the paper. But the basic thing is exactly they are there to perform some specific functions, like one simple task they are doing, not many, but one simple task they are doing. So this is what is the function of your embedded systems. So I'm not going in detail because this is something that you can but answer yourself also. That is not a difficult thing. A separate video for this is also available, so you can watch that also if you really have any query regarding the embedded systems. Now moving on to any questions before we proceed to the next topic. But what you need to know is the pros and cons of the embedded system. So you just see small devices means easy to fit. Compared to other systems, they are relatively low cost, like they are less costly. Usually dedicated to one task means simple interfaces and often no requirement for an operating system at all. Then they consume very less power. They can be controlled remotely also during using a mobile phone. They have very fast reaction to changing input. With mass production comes reliability. Like with the passage of time, they have become very reliable because we have been using them for quite some time, so we know how reliable they have become with the passage of time. Drawbacks: difficult to upgrade some devices to take advantage of new technology. Definitely, it's difficult to upgrade. Troubleshooting faults in the device becomes a specialist task. It's not easy. It's not easy to troubleshoot where the problem has occurred, in case if it has occurred. although the interface can appear to be more simple, for example, a simple knob in reality, it can be more confusing. For example, changing the time on a cooker clock can require several steps. These are some simple drawbacks. Any device that can be accessed over the internet is also open to hackers. This is what you can see. Anything that is available on the internet is definitely susceptible to some sort of cyber attack. Due to difficulty in upgrading and fault finding, devices are often just thrown away rather than being repaired, which is actually making it wasteful. Can lead to an increase in throwaway society if devices are discarded just because they have become out of date. Now, again, this has been happening with the people, especially in the West. Once it is not being used, and what they do is they just discard it, they just throw it away. So that is what I suggest you. You need to know the term embedded system. What is it? What is it dealing with? And then the benefits and the drawbacks. And then, inshallah, you'll be through with a question that is dealing with embedded systems. Now, in examples, as I talked about, motor vehicles, set-top box, then we have security systems also, like I talked about the use of it in our you can say daily lives. You can see it in vending machines, you can see it in the lighting systems. The main process is nearly the same, but you can see like washing machines, we see it quite often whenever we are using some household devices like micro washing machines, microwave ovens, refrigerators. They all are containing some sort of embedded systems. So any questions before I proceed to the input devices? We have just recapped. I'm not teaching you at the moment. I'm just recapping so that you all can recall what you have to study. Yes, any questions? Okay. Now, barcode readers, again, I'm telling you, you don't have to understand and rote learn these things at all. But what you need to know is the application of barcode. Where is it being used? By the way, where is it being used? Applications of barcodes. They are used on the stock items to be read faster. But one thing that you need to know are the input devices and output devices which are used at your terminals. Yes, exactly. You have it on the CIE papers. Yes, exactly. So the barcodes are present there to be read by the barcode reader. So in keypad and your card reader and touch screens are your input devices. So if a question comes in the paper that you need to know and mention the input devices that you can mention very easily, keypad, then card reader and touch screen. And for output, you can talk about screen, speakers, and printers. That's all. And their applications, why are they being used? Now, moving on to this simple, how is it being read? Again, you can observe yourself when you are standing at the terminals, POS terminals. You may have observed that how the barcodes are being read. Simple process: barcodes searched in the database. If found, it's returned with the values that are present in the equivalent values. Like the prices are mentioned there on the screen, and then automatic stock update is the basic advantage of using your barcode terminals. So then it is automatically updated every time a transaction is being made. And one important thing that you need to know is it helps you in, you can say, automatic reordering. And basically, it's a use of a flag. The moment the stock item is sent, so it will be actually updated immediately. And that is what you need to know regarding the barcodes. Simple, very simple. Okay, now one question that can come in the paper is the difference between QR codes and barcodes. That can come in the paper. Again, you can see one is the capacity. Barcode is holding lesser values as compared to the QR codes. Second is the application. Barcodes are used at the different items on in supermarket, while QR codes are present on the items. They can be read by the QR code scanner, which can be installed very easily on a smartphone also. On the contrary, for barcode to be read, we need a specialized barcode readers that is available only at the supermarkets. And so these simple things, you just sit when you are sitting for the paper, a question like this comes in the exam. Do not get worried. Think about it and then you can answer. Just remember the rubrics. First one is capacity. Second one is application. And third one, you can talk about like where is the application and then some advantages and disadvantages. In this manner, you can very easily score regarding the differences of, about two things. Now, Again, digital camera, very simple. You know the digicams, what are they meant for? Simple application, that is what you need to know, nothing else but what digicams are meant for. Not at all what happens when a photograph is taken. Please, I'm telling you again, you don't have to rote learn this at all. Keyboard, simple. By the way, if I ask you if a keyboard is pressed, I saw one of the questions similar to this one in the paper. So what happens when keyboard is pressed? When any keyboard on the keyboard is pressed. So it completes the circuit and its equivalent ASCII value is going to be returned. And this is how the input is shown to you on the screen. For example, if I have pressed capital A, so definitely capital A's ASCII value is different from small a. So if the caps lock is on, it means all the type values are in capital. So definitely it knows the ASCII value is for the capital letters and will return the value there. And on the contrary, if it's a smaller a that is being pressed, so definitely the ASCII value for smaller a is different, so it will be returning that also. One important thing that you can know is the use of RSI, repetitive strain injury, that may happen if you are using the keyboard inappropriately, like for a longer period of time without taking some measures that you need to take. So you may suffer from RSI. This is a simple thing that you need to know. This is what I was talking about. The moment you press a key, the key will be completing the circuit, and the completion of circuit means resulting in the finding out the ASCII value and showing it on the screen. So this is how the whole process goes on. Again, for microphone, what you need to know is microphone is an input device. It's there for giving the instructions to the computer system for performing any activity. And mouse, simple. Just mouse is your pointing input device. That's all what you need to know. Not much regarding the mouse also. Again, 2D and 3D scanners, something similar to which I suggested you. Just go through the application. By the way, what is the difference between 2D and 3D scanners if I ask you? How are they different? What is 2D scanner doing and what is 3D scanner doing? Come on. 2D scanners are actually, yes, exactly. 2D scanners are very much similar to the OCR. So if the word OCR comes in the paper, means they are talking about the optical character reader recognition, the scanner that is there to read any document, and the document is stored as a file or as an image on the computer system that can be edited using the required software. So that is what a 2D scanner is doing. And on the contrary, 3D scanner, as you can see, it's used in your you can say X-ray machines, and you can see the use in MRI, CT scanners. They all are using the 3D scanning process. So this is what is the thing that you need to know regarding 2D and 3D scanners. Then it's touchscreens. Simple that you need to know is touchscreens. What are they doing? What are they meant for? Just minimizing the user input, and they are there to help out with the minimal use of the you can say anything. A person can use it very easily, and it is going to make your work a little faster. Just the names, not the details at all, please. I don't suggest that you are going to go through all the details at all. Just know what are the three types of touchscreens that you need to know: capacitive, infrared, and resistive. And most common method is resistive, which because it is using plastic and a glass there. So completion of the circuit is going to, but this is something which is commonly used in all the three touchscreen technologies, that they, once the circuit is completed, then they are going to start the process once again. Like they complete the circuit and then they do an activity based on the locations where the screen is touched. The simplest of all these three is resistive. Now, this was just the input device, is not a difficult thing to do, but what you need to know is microphone is an input device, not an output device. I've seen a number of students, good students also, that under the examination pressure, what they do is they make a mistake and then they write down that microphone is an output device, which is actually completely wrong. Actuators, by the way, actuators, where have we read? Where should we use them actually? Actuators are there, are output devices. They are there to help you in some sort of closing of the valves, opening of the valves, opening and closing of the motors. So this is what the application of uh, exactly embedded systems We'll talk about the same in our sensor topic also. So actuators is again an important topic that you all need to know. Projectors, what are projectors meant for? What is the main task of a projector? They are meant to give you outputs to a larger audience. Whenever you need to give the output to a larger audience, then we go for projectors the way we have it in schools, just to address a larger audience. Now moving on to the advantages and disadvantages, you can just very slightly go through the advantages and disadvantages of digital light projectors, which are DLPs and LCD projectors also, but not in detail. Same case goes for inkjet and laser printers. By the way, applications and the two technologies we really know about the inkjet printers technology, simple, thermal bubble and piezoelectric. Thermal bubble, as the name implies, is for when it's the heated, then it is going to produce a bubble, and it will be once the heat is once the heat is provided to the ink which is present in the inkjet printer, that heat will vaporize the ink. It will form bubbles, and these bubbles will fall into the paper, and they will form the image, or you can say they will print the text also. But remember one thing, inkjet is a character printer because it prints character by character. On the contrary, laser printer is a page printer because it composes the whole page in a go and then prints the whole page all together. So this is what you need to know: thermal bubble, piezoelectric, the two technologies, and then the 3D printer also. By the way, applications, you can see the inkjet printer is there for printing what? One of photos. Like for the best thing is it is producing very good quality photographs. And on the contrary, when you want to print in bulk, then laser printer is my choice because laser printer is producing high quality prints at a faster rate, and definitely the cost per page is low for laser printers, but they are not available mostly in color. If you want to print in color, the best option is going for inkjet printers. Now, 3D printers, by the way, their applications, and inshallah, we're going to talk about this again after we are rejoining. Okay, so let me just go once again, I'll be starting the session with the same ID, and you can just join with the same ID. 3D printers are there for CAD and CAM, computer aided design and computer aided manufacturing. So simple, what you need to know is the application of 3D printers. And what I suggest you is you need to know the applications and uses of 3D printers here. Prosthetic limbs are created, aerospace, fashion and art, making parts of the items no longer in production, for example, suspension parts for a vintage car, and that will actually be quite sufficient for 3D printers. LCD and LED screens, by the way, the ones, LCD, liquid crystal display, and LEDs are light emitting diodes. So which ones are the next output device is LCD or LED screen. So what you need to know is the LCDs, what are they made up of? They are made up of tiny liquid crystals, and they are there to produce the image on the screen. And you can see, because LCDs don't produce any light, LCD screens are backlit using light emitting diodes, and must not be confused with pure LED screens at all. Use of LED backlighting gives a very good contrast and brightness is given to us. Because before the use of LEDs, LCD screens used cold cathode fluorescent lamps, CFL, as the backlit method. So there are progressions in the different technologies. Now, moving on to the LEDs, why are they becoming popular? So what you need to know is the main thing that, like a question, maybe hardly 2 or 3 marks question can come in the paper. So do not get worried at that time. Okay, why have I lost the marks for that? So LEDs are going to be reaching the maximum brightness almost immediately. LEDs give a brighter light. LEDs produce a brighter light. LEDs last indefinitely. LEDs consume very little power. So these are the 5 major points. What you can do is just underline these or make them write them down, and you will be through with your whole work very easily. Moving on to OLEDs, which we normally talk about. What is it based on? How is it formed? Again, not to be prepared for the papers at all. You can learn it for the purpose of learning. But the advantages of OLEDs as compared to LEDs. You can see for yourself the plastic organic layers of OLEDs are thinner, lighter, and more flexible than LEDs or LCDs. You can see they are lighter and made of plastic rather than glass. They give a brighter light than LEDs. You can see, since they do not require backlighting, That's why they generate their own light. Since they are not needing any sort of backlighting, they use much less power than LCDs also. They are essentially plastic. They can be made into large, thin sheets. This means they could be used on large advertising boards also. OLEDs have a very large field of view, about 170 degrees, which makes them suitable for use in television sets and for advertising screens. So the latest televisions are definitely dealing with OLEDs as compared to any other thing. So I hope that this is making sense to all
Right.
of us. Lastly are the loudspeakers. So loudspeakers are your output devices. Either you say loudspeakers completely or you say speakers, that's perfectly okay. Output devices that are producing sound, and just remember this diagram. Output from the computer system is digital in nature. So what are we doing is we are using DAC, which is digital to analog converter, to convert these signals into analog, sent to the amplifier, and the amplifier will increase the wave. You can say the waves, and you can see that it's sent to the loudspeakers. In this manner, the loudspeakers are able to produce the sound. So this is what you need to know. Most important is loudspeakers are output devices and not input devices. Any questions regarding input and output before I proceed to the next very important topic of sensors? By the way, in sensors, what you need to know is what are sensors? Input devices. And what are they doing? They are actually taking input of the physical quantities, physical properties. And the moment you are talking about the data sent to the computer system, remember it's the form, there's the term digitization that you want to talk about. You need to talk about because sensor readings are analog in nature, which are not understood by the computer. So they are digitized, or you can say they are converted into digital form using ADC. So once they are passed through ADC, they are digitized. And then they will be compared by, yes, exactly. You're absolutely correct. They are then compared by the preset values. And if the preset values are like, if they are not matching with the preset values, then the action is performed repeatedly till the time your required set is achieved. So this is what is the whole process. What you need to know is a little bit of the different sensors and their applications. This is very important. Like for example, temperature sensor, moisture sensor, and then we have humidity sensor, light sensor, infrared sensors, and pressure sensor, acoustic or sound sensor, gas sensor. Specifically, if it's dealing with oxygen sensor, you can mention oxygen sensor also. pH sensor. Then we have magnetic field sensor. The applications also, you can see the applications are in mobile phones and CD players or in ABS. Anti-lock braking system also are using, okay, fine, that's wonderful. Then accelerometer and proximity sensor, flow rate sensor, level sensor. A question can come in the paper to just state a sensor or maybe two sensors when an application is given to you. So it's again very simple. You can easily score 2 out of 2 or 1 out of 1 if you have understood the question properly and you've mentioned the right sensor there. That's perfectly okay. Fine. Now, most important thing, the question that comes in the paper is how the sensor readings are helping the monitoring or controlling applications. By the way, I hope that we know the difference between monitoring and controlling, isn't it? Do we know? Monitoring simply means observing. And if something goes wrong, then we are going to either hear an alarm being rung or a message is sent to us on the screens. On the contrary, when we say controlling, it means some corrective action is also taken. Like for example, you can see opening or closing of the valves, or you can say the moving of certain things, or like opening and closing of the doors. This all is actually your controlling applications. So what you need to know is just the basic steps. Remember that the way we talked about in the class also. So the same thing is going to happen here. You just need to know sensor readings taken by the uh, by the sensors. The sensors are in the digitized form, means within brackets for your own self, you can write down that it's ADC role. The data is sent to the processor, or you can say the computer. The computer will compare the values with the preset values, like whatever is the range that you have set. Maybe, for example, the temperature sensor is there. It has taken the readings of the room, and if you have set a certain value for the temperature, so it will keep on checking the values of the room temperature, and the moment it has reached the desired level, it will stop the work for a certain time period because it has reached the desired level. And again it will start the process once again, and this process is going to be repeated. Once and it is the role of the feedback loop that is very important as far as your controlling applications are concerned. So you can see here, till this point, it's the same. A sensor readings taken, signals sent to the, after passing through the digitizing process, they are sent to the processor. Processor is going to compare with the preset values, whatever is in the question. You need to see the question, read it, and you can see for yourself. And remember, in the paper, they have normally mentioned the word controlling or monitoring. So what you need to know is just simply take the question and understand what you need to do. Outside the range, a message is sent if you are at a distant place, or an alarm is activated the way it is done for the patients in a hospital. And then it will just observe the process, no corrective action is taken in monitoring. While in controlling, it is the use of actuators to control the motors or to control the movement of the valves or anything like that. And this input, the output is going to affect the next input. And this is going to be repeated using the feedback loop. So the role of feedback loop is also very important. You can actually score 1 mark if you mention the role of feedback loop there. So this is how you can solve the questions, and you can score very easily a 5 mark question if it comes from here, or maybe the same topic is covered in chapter number 6 also. So in this manner, you can understand and answer very easily. But remember to follow the sequence. Now, this is just an application. Different applications like the controlling of street lights is basically one controlling application. The ABS also is a controlling application, and monitoring of patients in a hospital, or you can see the temperature temperature again is being controlled in greenhouse also. So these are all the applications of your controlling applications. Again, greenhouse, you can see a list of different sensors being used there are mentioned along with what they are doing, and you can very easily score, believe in me, if you have understood and remembered the whole sequence. It's very easy. Now moving on to the next very important topic, data storage. Yes, a lot of questions are coming nowadays regarding the primary storage and the secondary storage, primary memory and secondary memory. So just remember, primary memory is accessed directly by the CPU, and secondary memory is not accessed directly by the CPU. So what you need to know is, by the way, you can bifurcate say secondary memory in secondary storage or secondary memory into internal or external. Internal is basically hard drive and solid state, and external is your DVD, CD, and DVD RAM, Blu-ray discs, and then USB flash memory, or you can call it a memory stick also, and removable hard drive. What you need to know is just the differences between primary memory and secondary memory. In the recent paper, they have asked us to write two differences between primary and secondary. So just remember, this is how you can score very easily. We talk about primary, accessed directly by the CPU, and secondary is not accessed directly by the CPU. Same case goes for the point regarding contains RAM, ROM, and cache. On the contrary, if you talk about secondary, it is your, you can say, HDDs and SSDs, or maybe DVDs and memory sticks also. And one more thing is, usually primary memory is volatile, usually, because in this category, RAM and cache are volatile and ROM is non-volatile. That's why if you are talking about the third point, third difference, you can mention primary memory is RAM. Usually it is volatile, while secondary storages are always non-volatile. So this is how you can answer and score. This is the recent question that has come in the paper. So please be clear about it. By the way, what is ROM storing and what is RAM storing, if you can recall? And the different types of RAM are SRAM and DRAM. Yes, can we quickly recall the what is stored in RAM? You can see this is very important. It is used to store data, files, part of an application or part of an operating system that is currently in use. Just remember these 3-4 points regarding RAM. RAM is volatile, that you already know. RAM is primary, that is what you already know. Yes, okay. Now, moving on to what is stored in ROM is your booting instructions. And on the contrary, what is stored in RAM is data, files, part of the application or part of the operating system currently in use. So I think we are clear about RAM and ROM, yes or no? By the way, out of these two, which one is faster, DRAM or SRAM? Very quick recap. DRAM is slower, but DRAM is less expensive, it consumes less power, it has a higher memory capacity. And this is what we normally use. On the contrary, SRAM is using flip-flop, and while DRAM is using capacitors and transistors. So this is how you can actually make a difference chart for your own self also. I'm very quickly recapping because we have to study, like revise a lot of chapters. Quick recap is only done here. So just remember, DRAM is using capacitors and transistors. DRAM is less expensive. It is consuming lesser power. It has a higher memory capacity. On the contrary, SRAM uses flip-flop. It's faster than SRAM, and you can see this one is the same because it doesn't needs to be constantly refreshed. That's why it is faster. And cache memory, the one that we talked about earlier, is basically SRAM. While ROM is non-volatile, ROM's contents are never deleted. ROM's area is limited, it's very small, and it is normally storing the booting instruction, the BIOS. So ROM BIOS is another word that we use for ROM. And another word for this is boot startup instruction, the way we have been talking about, or bootstrap. So just remember these key terms. If they come in your paper, you should be able to answer. So startup instructions or bootstrap are actually held in your ROM. So any questions before we proceed to the secondary and offline storages? By the way, magnetic, optical, and solid state. This is what we need to know. What is magnetic actually? Which things come under the heading of magnetic? It's basically your hard drive. Magnetic also has some, you can say, advantages as well as disadvantages. And optical means it is dealing with your laser, with your like laser technology, and it's the CDs, the DVDs, the Blu-ray discs. So if I talk about hard drive, what you need to know, I'm just talking about the key terms. First thing, when it comes to the hard drive question, if it's a 4-mark question, you need to talk about tracks and sectors. You need to talk about the cylinder. You need to talk about the way it is actually spinning and storing the data on it, and platters. And you can even talk about latency, about also, you can also talk about defragmentation, fragmentation. You can even talk about the advantage, that is, its life is a little longer. So this is how you can very easily score 5 out of 5, even if the question is coming from hard drive. So we are anticipating that you make it a question that deals with hard drive. So simple, remember, you talk about tracks and sectors. Tracks are your, you can say tracks are these things that are, you can see here, the round ones are tracks, and these tracks are divided into sectors. And each sector can hold a certain number of bytes. And then platter, basically the platters, the top and the bottom surface of your disk is forming a platter. And all these platters are spinning at about nearly 7,000 times a second. Read-write heads, by the way, read-write heads are there, which are there to store the data on the hard drive and to read the data from the hard drive. So the role of read-write heads is also important. And then you talk about the data stored on tracks and sectors, which I've already talked about. By the way, latency, what is latency actually? Latency is defined as the time it takes for a specific block of data on a data track to rotate and reach the read-write head. So this is what the latency is. Just very simple. Sometimes when you are giving a lot of tasks to the computer system to perform, what happens is computer system or hard drive is constantly moving backward and forward. The read-write heads are constantly moving backward and forward. Then a situation may come that it is going to talk about the system is not going to respond at all, and that state is called your latency. And this problem is resolved in solid state drives. There is no problem of latency in SSDs at all. So this is how you can answer very easily in your paper. But what is fragmentation? Again, if you can recall, fragmentation and defragmentation together, we can cover it for chapter number 4, also, which is utility program. Fragmentation, whenever you are storing the files, so they are always stored like in pieces in different locations. So they actually become fragmented. And remember, fragmented files are always taking longer to be read as compared to non-fragmented files. So this is also a problem with your hard drives, that the data that is stored on a hard drive is fragmented. It's actually going to result in deterioration of your system performance, of your hard drive performance. On the contrary, the life of a hard drive is longer. That's why it is still used. It is still, can say, popular because it is used in different applications. Now, removable hard drive. This is your secondary storage, again, external secondary storage, and we use it for backups mainly. Like we use hard drive for storing the actual data, and we use this for storing the backup data. Now, SSDs, advantage. SSDs are reliable, SSDs are lighter, and being lighter sometimes become a disadvantage as well. Do you agree with this? Yes, if I say SSDs being lighter is an advantage, perfect. But I can also say, they can also ask that it's a disadvantage also. So how is it becoming a disadvantage? Yes, can we think about it and answer that how does it become a disadvantage? It's simply the if it's actually smaller in size, then it can be lost very easily. So this is how you need to understand and remember that since it is lighter, fine, but still it may be possible that if you're talking about the SSDs in the form of your USB flash memory, please, not the normal SSD used in laptops. I'm talking about SSDs used in your flash memory. So in that case, it is possible. It may be possible that your SSDs are going to be, you can say, lost easily. They don't have to get up to speed to start their work. Lower power consumption, run much cooler. They are very thin, and data access is considerably faster. So the most important thing is data access is considerably faster than HDDs. So this what is the advantage of your SSDs. Now, problem of latency is resolved here in SSDs, but the drawback of SSD is its SSD endurance, not very long life. So this is what the thing actually is. Now moving on to memory sticks, you can see it's a form of SSDs, and then it's the optical media. Any questions before I proceed to optical media, CDs and DVDs? Yes, any questions before I proceed to optical media? Now, very simple. CDs and DVDs. CD is single layer and DVD is dual layer. And the use of red laser is used in CDs and DVDs. And when we talk about the Blu-ray discs, they are using the blue laser. By the way, dual layering definitely increases the capacity of your DVDs. And what kind of data is stored in CD and what kind of data is stored on DVD? Very simple. Normal software, your images are all stored on your CDs. And if I talk about the DVDs, they are there to hold the full length movies. They are there to store the movies basically. Now, how the data is stored, this is what you need to know. The term pits and lands. So, and the spiral track that is being used, and you can observe yourself that it's a single spiral track which is starting from the middle of the disc to the end of the disc. That is what you need to know regarding the optical media, that is CD and DVD. Why am I emphasizing on these points is, once I start solving the paper with you, the March 24 paper, that is like I was just solving it recently, it is dealing with a lot of terms which students need to know. So if you actually remember from now onwards that it's basically the use of one single spiral track that is running from the uh, okay, now exactly, you are absolutely correct. You are absolutely correct. I 100% agree with whatever you are sharing, Yaya. But this is what is definitely we need to know also. We need to know the way things have been developed in these recent years. Okay. Now, one more thing is the use of R and RW. When you talk about the R, that means it's write once. It means that when we talk about CD, it is coming to us for, like, the data is already present there. I can't read the contents. I can't, you can say I can't edit the contents. But on the contrary, if I say I have bought a CDR, it means it allows me to write on it once only. And that is non-deletable. It becomes a permanent, can say yes, a permanent sort once the data is written on it or the data is burnt on it. On the contrary, RW, which is actually, you can say rewritables, are allowing the data to be read from or written to many times. Now, dual layering I've talked about just now. Dual layering means the data is saved on both the surfaces of your DVD. Now, Blu-ray, what you need to know is Blu-ray is again optical technology. The difference between this and CD-DVD is it's using the blue laser as compared to the red laser. And definitely the capacities are also very huge as compared to your CD or DVD. And what are they meant for? They are meant to store the movies, the full-length movies are stored on your DVDs. Basically, they are meant to record high-definition television programs for a better storage. And definitely they produce a better, I can say, a better storage as compared to CDs or DVDs. Again, remember, I'm talking about optical. I'm constantly repeating optical means CD, DVD, or Blu-ray, the one that is shown here also. Now, moving on to any questions before we proceed to virtual memory? Yes, any questions? Virtual memory, as the name implies, is something that is again a very important thing actually. Your RAM may get full. It is possible that you have opened many programs and RAM is not having enough space to accommodate all the programs. So what happens is in that situation, the RAM is going to give us the impression as if I'm full. I'm not having enough space to cater to you. In that situation, the empty space of the hard drive comes for my help, and this empty space of my hard drive is called the virtual memory. So just remember the diagram itself is very self-explanatory. The moment you talk about accessing a normal situation, more processes open and less memory available. So it may result in maybe some maybe open so many applications are open. So what may go wrong is then just remember one point. Empty space of the hard drive used as RAM is your virtual memory. So there isn't enough space, then still you will experience the same problem, Yahya, as you have mentioned right now, that your system will still give you a lot of problems because you don't have enough space on your hard drive. That's why the best thing is you keep on cleaning the hard drive for all the unnecessary data that is not needed. Okay, that's just a suggestion. Now moving further, with virtual memory, what happens is you can see for yourself, just diagram is very helpful in making you comprehend. And by the way, nowadays, we are getting questions regarding the drawing of the diagram also. So if you have just paid attention to this one, now with this one, what is happening, whichever task is not being accessed quite often, the task is something that is idle, that idle task may move to hard drive, empty space of the hard drive to give space to a new program or maybe some other program in the waiting list to be accessing the RAM. That is perfectly possible. So now this is what is the whole process of your virtual memory. In this virtual memory concept, you need to know a few terms like paging and page. What is paging? It's a process. And this is used by the memory management to store and retrieve data from hard drive or SSD and copy it into RAM. So just remember the term paging. It's used by memory management to store and retrieve data from hard drive or SSD and copy it into RAM. And a page is a fixed length, consecutive block of data utilized in VM systems. So these two terminologies you should be aware of. Besides this, you need to know that you keep on definitely swapping the data perfect. But it may happen that your hard drive, virtual memory, when using hard drive for virtual memory, the drawback is disk thrashing. And what is it? If your main memory fills, more and more data is trying to be swapped in and out. Like it may happen, your RAM is full. Definitely, there's more data which is moving in and out of your virtual memory, with that is your hard drive. A point may come that your hard drive, the same way as we talked about right now, may experience a sort of read-write head movements, a lot of read-write head movements. And this may result in hard drive not able to process the requests the way it was able to process the requests earlier. And this is called disk thrashing. So along with paging and page, you need to know this term also. Disk thrashing means you have been like this all is done by the operating system. I'm not doing anything. It's all done by the operating system. So once the disk thrashing is happening, there's a point at which this thrashing occurs, and that point is called thrash point. So along with that, you need to know a few terminologies. One more is disk thrashing, and another one is the thrash point. A point can be reached when the execution of the process comes to a halt, since the system is so busy moving data in and out of the memory rather than doing any actual task. This is known as the thrash point. So I hope that you are clear about these terminologies, and what I suggested you is please look at this diagram. A question like this can come in your paper to draw and annotate a diagram. So if you are able to understand this, only then you will be able to prepare a good answer. Yes, it may happen. Whatever you are asking, it may happen. Definitely, these things do happen, and we are just only shown that our system is not performing. So what we see is our system is not performing as per our requirement, but in reality, it can be due to any of the reasons that I have talked about right now. So are you clear? Any questions? Virtual VM system is actually a very important topic. Before we proceed to the next topic, any questions that you have, then you can ask. Yes, are there any questions regarding this trashing, VM systems, page or paging? Okay, that's wonderful. Now moving on to cloud storage. A question can come, very simple question. What is cloud storage? You know that, by the way, data stored away from your local computer onto a remote server is basically cloud. And they're definitely having some advantages and disadvantages. But the basic advantage is uh, actually virtual memory is the use of your hard drive's empty space as your RAM. So that is why it is given the name virtual memory. It's not real memory. So that is why you can see virtual memory is actually something that is using your hard drive's empty space as your RAM. Okay, that it can actually swap the data that is not needed, and it can have a more space available in RAM for the data that is worked upon. Now moving on to cloud. The three common systems are public cloud, private cloud, and hybrid cloud. As the name implies, public is going to be managed by, you can say, the providers, and the customers are different companies. Private cloud is a dedicated environment behind a company firewall, and on the contrary, hybrid, as the name implies, is a combination. Now, moving further, we have the advantages and disadvantages, benefits and drawbacks. Very simple. I hope that you can see for yourself. Very simple advantages is I can access it from anywhere. I don't have to carry my computer system, my hard drive anywhere. I can access the data from anywhere if I have the internet connection, and that can be definitely. I'm not even concerned about the backups also. The cloud providers are maintaining the backup of my data also. If something goes wrong, they will be definitely having a backup to retrieve the data from. So I am actually not, can say, not worried about the backups of my data at all. Now, on the contrary, if you talk about the drawbacks, if there is a slow or unstable internet connection, then that is not going to be of any use at all. And cost can be high if you are using a lot of storage, like you are going beyond the allowed capacity, then you have to pay for the cloud storage, can say, buying. And it is also possible that it is like definitely a risk of, you can say, always there, that some sort of data can be in danger also because of anyone accessing your data also. Like there's still a chance that your data will be accessed if the cloud is accessed by anyone. So then these are the few drawbacks or benefits that you need to know. Exactly. Yeah, you are absolutely correct that they are using it for their own use, and still we do have, like I said, we have this thing in our mind that maybe our data will become available to them. That's perfectly, you're perfectly correct. Now, moving on to the next topic, again, a very important one is MAC address. By the way, network hardware, NIC, and NIC means your device that is needed to connect you to the network, like the internet. And with this, the term MAC address, by the way, MAC address, again, a very important term that can come in the paper, and that has come in the paper. I'm not saying that can come, it has come in the paper. This address is a fixed address that doesn't change. And this is written by the manufacturer. It's a 48 bits address, which is taken this form. And this is denoting the manufacturer's code, and the last values are denoting the device serial number. It's a hex value, and it's always unique. It's never going to be duplicated, and it never changes, even if it changes the place. On the contrary, if I talk about the IP address, IP addresses do change once the location changes. So We talk about the MAC addresses, we talk about the IP addresses. The question can come in the paper regarding the explanation of MAC address, maybe 2 marks question. So you need to know how to answer to gain 2 out of 2. So you need to learn the technique of answering and gaining marks from the examiner. So my major concern is telling you how to answer. Types of MAC addresses, if you really know, UAA and LAA. The one that is fixed one is UAA that never changes. And on the contrary, we do have LAA, which is a changing one. And this changes very rare situations, not by us, not by all of us. Like it's not something that is a norm, but in some situations, it can be changed also. Like maybe some mainframe systems want all the MAC addresses to be following a certain format, or maybe to bypass a MAC address filter in a router or firewall, we need to have MAC addresses follow a certain format. Then they can be changed also. So there are certain situations where the MAC addresses are changed only. Otherwise, the MAC addresses remain constant, which are your universally administered MAC addresses, or which we call them UAA. Any questions? By the way, one more thing that I'm telling you is we can have a MAC address of 64 bits also. Like maybe it means one more set of PD is going to be here, and one more set of NN will be here, and that makes your MAC address to become a 64-bit address also. But just to expand the network, we may have MAC addresses which are 64-bit addresses also. Fine. Any questions? Now, IP, a very simple thing which we keep on hearing quite often. IP address is assigned by the ISP, Internet Service Provider, and that IP is either IPv4 or IPv6. So here you can see this is IPv4, which is actually a denary number, and this is of 32 bits. So you need to know IPv4 is a 32-bit address, while IPv6 is a 128-bit address. IPv4 is, you can see IPv4 is a denary number, while IPv6 is a hex value. Second thing is it's storing more data IPv6, and as compared to, yes, exactly. IPv6 is the future technology, and on the contrary, you can see for yourself, this is your IPv6, which is composed of hex values. IPv4 is separated by a full stop, a dot. On the contrary, IPv6 is separated by a colon sign. So these are the 3 differences. A question can come in the paper regarding the difference between IPv4 and IPv6. So this is how you can score very easily by mentioning the bits, number of bits. V4 is 32 bits and V6 is 128 bits. Secondly, it is going to be the use of denary number, and hex value is for V6. And thirdly, you can talk about the format. You can even talk about the format also. And that will also give you a mark. If you mention any format like this, that will give you a mark. But remember one thing, the maximum value that can come in one is not beyond 255 because it's a byte. And you remember a byte cannot go beyond 255. So even they can ask you a question in this manner, that they can give you an address that is a wrong address, basically. Like they may write 300 and they may ask you, is it valid or invalid? So just by looking at the value, you can judge that since it is containing 300, which is not an acceptable value, maximum is 255, means even 256 is invalid. So this is how the questions can be framed for us. I mean, you need to be well prepared for any question. Yes, exactly. This one I keep on suggesting the students that just underline the key things, that you are not able to miss out anything. The same goes for different topics. Like this one, I have been giving you the hints repeatedly. Now, one more table here, the same as I discussed here is the same discussed here also. MAC address and IP address is the differences. So something similar to what I have talked about. Now, very important thing is dynamic IP and static IP. Any idea about the term dynamic IP? Dynamic, as the name implies, is changing IP, and static IP is something that is a fixed IP. So we as consumers get IP that is changing IP, that is dynamic IP, and the fixed IP is for the web servers. Static IP is given to the web servers. The 2 IP addresses that we need to know are dynamic IP and static IP. So very first thing that we need to know is dynamic IP is a changing IP, the way we get it. And on the contrary, static IP is something that is a fixed IP that remains same no matter the situation or whatever. Now you can see here the diagram is, again, why am I concentrating on diagrams repeatedly is we can get a question regarding this to be annotated and drawn also. So this is why I'm concentrating on these simple things. You can see this is my device. Assume this is my device. I want to access this website or URL. By the way, can a computer understand the URL better, or can a computer understand the IP address better? So what do you think? Which one is easier for a computer to work on? Which one is made for it?
I guess the IP address.
Exactly. And that is why you can see the first role is DNS, domain name server or domain name system. And what is it doing? This is already covered in chapter number 5 also in detail, but just let me revise. This is a server that is containing the URL and the equivalent IP addresses. So if it's able to find out the equivalent IP, it sends the IP address back to the computer system, to the device. So this is the first stage. You can see, firstly, it's sending the device, sending the URL to the DNS, and the DNS is going to actually definitely send the address back. But before that, you need to connect to the computer system. You need to connect to the internet also. And here the role of DHCP server. So here the DHCP server is something added here. What happens is I have turned on my router. So what happens is I am accessing my DHCP server, and this DHCP server is going to allot me an IP address, and that IP address is going to be for a short duration. The moment I switch off my system or my device, the IP address becomes available to some other PC. So this is a dynamic IP assigned to me for a short duration. And once I'm connected to the internet, I'll connect through the DNS server to the required website address. So this is again the same thing. I opened my system, I connected to the internet. The DHCP server's job is to send me an IP address. The IP address is going to be actually connecting the device to the internet. And then you have typed in the URL. The URL will be searched through the DNS server. It will be returning the equivalent IP address. And now you can actually access the IP address using the IP address, the website server. And you are then sent the required web page on your PC. Again, you are accessing the IP, you are accessing the IP addresses, and you are sending the data also to the IP addresses. So in this manner, the whole process continues all the time. And then we talk about on the contrary, we have the static IP also. The static IP, on the contrary, has only the stage where the device is connected first to the DNS. No DHCP job is there, because we are assigning a static IP to the device that remains constant no matter the system is off or the system is on. And you can see we are connecting to the website. The DNS is assigning the equivalent IP address. And once I have got the IP address of the required URL of the website, then I can actually connect through the IP address to the required server. And all the required web pages will be sent back to me. So this is how the role of static IP and dynamic IP can be understood. And please just go through these diagrams thoroughly so that you can answer if it comes to the paper. Okay, I'm understood?
Okay, ma'am, inshallah.
The thing is explained a little bit here. I mean, the same thing. The way I've explained you, the same thing is mentioned here also. They've talked about the same concepts. But one thing is static IP addresses are assigned to remote servers which are hosting a website, the way I talked about, an online database, an FTP protocol server, which is going to be serving they are the servers which are used when files need to be transferred to various computers. On the contrary, DHCP is the role of DHCP is in dynamic IP addresses, and you can see ISP is assigning the use of DHCP servers is by the ISP to assign an IP address to a device for a short duration, and the moment you switch off, the IP address becomes available. So just very quickly, you can go through these also. The same thing is mentioned here also. And lastly, the last topic of this chapter is routers. So what are routers basically? Very simple thing. Routers are, but what do we know about routers? Simple. Routers are the devices that know how to send the data through the best possible path so that it can read the destination accurately. Now, the role of data packets being routed through different routes, and they are going to reach the destination. It is also meant to join a LAN to a WAN. So along with what we know, the basic job of router, we can also note down that it's there to join a local area network to a wide area network. Like maybe I am working in an organization, I have a local area network, and the local area network will be connected to the internet using the routers. Yes, exactly. You are absolutely correct. And a question can come in the paper regarding the job of routers also. And remember, it's also converting the data to a format or to a protocol understood by another network. So once the data is transmitted from LAN to a WAN, it has another job to actually convert the data to a protocol or format which is understood by the network, by the other network. It means it is working as an intelligent device. It's not a normal device, it's an intelligent device. And you can see a router would typically have an internet cable plugged into it and several cables connecting to computers and other devices on the LAN. Here the diagram you can see. Just pay attention to the diagram also that we have a computer, 1, 2, 3. We have a server, as the name implies, providing the services, and a switch. This is my LAN. We are using a router to connect this LAN to an internet or maybe to another LAN or maybe to another WAN. So this all is happening because of the routers. And you can see broadband routers are behind the firewall. And by the way, you all know that firewall is there to actually protect the network from any sort of unnecessary uninvited, you can say, IP addresses also. And it is just there as the security guard. The way security guard is interrogating every single person who is entering the network. The organization, similarly, the firewall is there, is going to interrogate, which is going to see that at what time, which website is trying to access the network. And if it's allowed, fine, allow. If it's not allowed, then stop the IP address to access the different devices. So that is what the job of firewall is. So I hope that this whole thing is now clear. They are inspecting the data packet sent to it from any computer on any of the network. Since every computer on the same network has same part of an IP address, the router is able to send the data to the appropriate switch. Now, this is very important. They're intelligent. They know that which device should be accessed at what time. So this is the end of chapter number 3. If you have any query, then you can ask me before we proceed to the next chapter. Yes, anything that you need to ask?